Hello YouTube. So today I will be doing a tutorial on C++, the first in a series, for C++ in command line. And I will be using a Mac terminal, but this should work exactly the same on the Bash terminal that you can run with like Ubuntu or other different things on Windows. Note that it will not have the same commands as if you are actually running on the command prompt that comes default with Windows, because that is not going to be Linux Unix based. But all Linux Unix based should work with similar commands as to what I'm using. And even if you're using an IDE, most of the code, if not all the code, will work exactly the same. I'll go in some differences with like compiling, but in general, there should not be too much of a difference running any of these things. And when I'm actually in Vim and typing the code, everything should be exactly the same and run just the same. Okay, so let's get started. So first, if you're not familiar, one generic command that is used a lot in the Bash terminal is ls, which stands for list, and that'll list the different folders that you have. So I've created a tutorials folder, so let me go ahead and move over to that. So you do cd change directory. Directories are called, or folders are called directories in Bash. Okay, and you can hit tab, and tab's the default. Since I already typed in tu, and there's no other tu folders, it'll automatically autocomplete for me. And when you hit enter, now I'm switched in, as you can see, where it used to be just tutorials, now it's tutorials, a little repetitive, but now that shows that I'm actually in the tutorials folder. You can do ls to see the different files. Here's the files that we'll be using, but for right now I'm going to go ahead and remove those, and this shows you how to remove a file. So rm.a.out, rm hello world.cpp, and then now if you do ls, it's empty. And also doesn't really pertain in this case, but if you ever have to remove an entire directory, you just do the same command, but you do -r. So it would look like this if hello world.cpp was a directory, which it can't be, or which it wouldn't be. So it would more look like that, because usually they're not going to end with file-specific names. This would remove the directory name and all the files that are inside a directory. But that's just a little extra info. So to get started, we're just going to do a simple hello world program today. It'll be using Vim, which is the default Unix like command editor, instead of using an IDE. And I prefer it as a student and just in general because it's much quicker than running an IDE, setting up the project and all that stuff. You just kind of get started and get going. As you'll see later, the IDE comes in useful as having more like, it's essentially using like Word, Microsoft Word, versus using just a basic text editor that doesn't have anything. But it's much quicker, and I like to use it in that sense, which is why I am doing the tutorials for this. Plus, lots of college campuses use it because it's easy to SSH into the different servers that are used to make your program go faster. Okay, so that was a lot of extra info, but let's go ahead and get started. So as you could already see, I named it hello world.cpp, but you can name it anything. .cpp ending shows that it will be a C++ file when compiling. So you just hit Vim, enter, and then for those of you not familiar with Vim, you will hit I to insert, and that just lets you start typing. And then you're going to do the # include iostream. And what this does is it gives you all the default libraries that come inside of the iostream class, or different like folder. And basically it's just a bunch of code that C++ already wrote for you in order to connect to things like the terminal and display and stuff. So this allows us to print to the terminal, get actually info from the user from the terminal, and different stuff like that. So most codes will use this because most of the time you have to print something or do something with your code. And then the next line that is often used, using Namespace Std. This is just using the standard namespace, and it just helps with certain commands. So for example, cout is a code that we're going to be using later. If you don't include this line, you'd have to put this in front of every single time you do cout, and it works with a bunch of other commands. And since the standard namespace is usually perfectly fine and has all the features that we need, that's usually what the namespace that you'll use will be. But if for whatever reason later on you have programs that are using different namespaces, you might not include this line and have to do things manually. Okay, so now for the actual code. So all C++ code starts with int main, and the reason that all the codes that you'll see have a main is because when you go to execute the C++ file, main is like a requirement. So what the code will actually do when running is look for the main function and start with that, and then later on you'll see that you can create your own functions besides main, and then it'll like call those within main. But it needs a main because that's where the compiler knows to look first to actually start your code. Okay, and then so inside of main, we have to pass what are called arguments into the function. And so in order to do this, we will just simply do the open parentheses, or the left parentheses, sorry. And then what it is int argc char pointer argv, and it looks like that. And then every function will have the opening and closing brace to show like this is all contained inside this function. So everything written in here will all be part of main. Okay, so don't worry too much about what was passed in there or just like in general because you're just starting out, but just give you a quick overview which will make sense in the long run. Int is means a number, and it has to be non-decimal, and what it is in this function, this is what your return type is. So in our case, main returns an int, and usually it'll be like a 0 or 1 indicating whether the program ran successfully or unsuccessfully. Then main is going to be the name of the function. And then int argc and int argv look really strange right now, but what it is when you're running your program, you can pass in certain command line arguments, and in order to do this, you need these two. So argc is just the number of arguments passed in, and char pointer is just a string, and the little square brackets right here mean array, so it's basically a list of strings. So say argc is 3, then you're going to have 3 different argvs or strings inside of it, and that will be like the different commands. So if you have a program that wants to pass in the word dog in order to run a certain application, then that will be inside the list of words that you pass in. And again, right now it's not going to mean anything, and for a while, because command line passing in is not something that's absolutely necessary at the beginning, and in general you probably don't necessarily need to do it. There's other ways around it when running, but that is why it is required and included in there. Okay, so now to get to the actual hello world part, we will do cout hello world. Go ahead and throw a couple exclamation marks in there, and line. Okay, so to break this down, cout stands for C output, and that is just how it prints to the terminal, so it'll print to the screen. Hello world inside parentheses is just going to be what is actually printed, and endline is endl stands for endline, and it's a special keyword that just makes it jump down to the next line after it's printed, and it just makes the formatting nicer, and I'll show you later what it looks like without that. And in a sense, you can kind of think of this as the plus, so you have cout, and then to cout, it's going to be hello world, and then I'm also going to add an endline. That's what those little kind of triangle left-facing arrows are, and they're required by cout. And as you'll see later, there's cin, which is getting input from the user. And in general, the way to remember, or at least for me, is the arrows are pointing left right now, and that's kind of pointing like out of your code and out of the screen, and that shows that it's going to print. And when we're doing cin, the arrows are going to be pointed inward, and that's kind of showing it's going to be going into the variable or whatever you're storing it in. So again, don't worry too much about these details. it'll make more sense when you actually see cin. But just giving an overview instead of just throwing code out there and just kind of expecting you to ignore it. Okay, so you hit escape key and then colon WQ, and that's how you save and quit. W is write, Q is quit. And yeah, so now it's saved. So now if you hit LS, you'll see that file that we just created. And now for C++, you use the compiler G++, and then hello world.cpp. And that's just the name of the file. So when you run that, nothing seems to happen. It just goes to the next line. And that's because we have no compiler errors. If there was an error in compiling, we would have seen it right there. And if you see ls, now all of a sudden it added a new file for us called a.out. And this is just the compiled file, and it's the executable that we'll run to actually have our code be run. So in order to run it, you do /a.out. And then this is just always how you run executable files, and then the file name. And when you hit enter, you'll see the hello world is printed out. So earlier I was referencing that, so let's go back into the code. So earlier I was referencing that we have end line and that it just made it look nicer. But instead of just saying that, let's go ahead and actually display it without. So save it again as before. And then G++ to recompile and a.out. And as you'll see, it just kind of continues on and makes it look strange. But if you'll see, the hello world is printed exactly as before. There's just no end line, so it doesn't go to the next line when we're trying to type in the next thing. So in general, most of your code will end with end lines because it makes it look nicer, but the reason it's not like built in is because say you wanted to print out a word letter by letter, you don't want to go to a new line every single time you're printing out. You wouldn't want that to happen. So cout is very specific. It'll do exactly what you tell it to, which is good and bad. Sometimes it doesn't make common sense, like why would you want it to look like this? But it does word for word, so it does everything exactly how you specify it to, which makes it very flexible and makes it able to do what you want. So now let's go in. We'll add back in that end line. And then just so you remember what it looks like, I'm going to go ahead and compile this again and run it. And it looks like before. So now another thing to note, which is kind of specific in a sense to the command line, let's go ahead and add in a bunch of exclamation marks. And go ahead and rerun this. So if I just go a.out and run it, something strange happens. It's exactly what it looked like before without adding all those extra exclamation marks. And that's because a.out doesn't automatically update. A.out is the kind of result of recompiling. So you must recompile and then run a.out, and now you'll see the update. So if you ever made a bunch of changes to a code and you run it and nothing happened in the sense of like it doesn't print out or give you different answers, it's most likely that you forgot to recompile before running the a.out. And another note on the a.out, the executable file, there's a way with just a flag that you can pass into G++ and change the name that it actually prints out. Instead of being a.out, I could make it hello world, but it isn't required, especially when you just have like one file running at a time and one thing compiling and running. Naming it a.out is totally fine, and that's how you should start with it. And then one last thing I wanted to show. So let's go back in to this. Let's say I do something like I remove the ending quotation mark, which is incorrect. This is a case where right away an IDE would catch it, underline it, squiggly, to do all sorts of stuff to let you know that something's going on. But part of the freedom and quickness that you get from using Vim, you also lose some of the different features that are built in. So now, if you go to compile, it'll crash. So it still is going to tell you that there's a problem, but it doesn't tell you instantly. You have to actually compile it. And you'll see that in this case, there's only one line, so it does a pretty good job. But sometimes you'll see a line, and it'll actually be the line before that's causing the error. In general, it's a very good compiler and will tell you what your problem is. But just note, it's not necessarily exactly going to be on the line. And you can see the green arrow, it is referencing the starting quote, but like it might make more sense to put a green arrow here to show you where you need to end it. So it's not going to be that precise in that sense, but it will get you in the right direction, especially when you have hundreds of lines of code. It's nice to narrow it down to, oh, the 50th line is probably the problem. And if not, then maybe it's the 49th line or so on. So let's just go back in, add back that quotation mark to get it running again. Important to recompile. A.out, hello world. And yeah. So another thing to note, as I showed, if you don't recompile, the A.out doesn't change. But also, if there's a compiler error, which I didn't show, it will not change the A.out because it never completely compiled because there was an error, and so nothing's updated. So don't expect A.out to change if your code does not successfully compile. Okay, I hope this was helpful. I hope you liked this video. If so, click like. And there will be more videos to come, hopefully making a whole series on these different tutorials. And then also going through different small problems and stuff in C++ to see how you put everything together and use it to solve new problems instead of just the basics.